G'day everybody and welcome back to my channel. Sorry about that. There we go. So I went to JCar. You won't believe this. I cannot believe this. I cannot bloody believe this. And you know what? I can bloody prove it. Check this out. My original transistors from the amp that I built literally 3 years ago. Not the two that I cloned from the original. The original. On semi. AFE 26. What do we got here? CHN 326. These are the batch numbers. 912. 920. 920. Anyway. AE26 on semi. 3 years later. I kid you not. Look at this. Sorry, my focus was locked. They still have the same batch. The exact same batch. Nothing's changed. I said to the guy, you guys must order a lot at your warehouse if 3 years later you still got the same ones. Look. See. I grabbed the wrong one. There's a couple of different batches. I've got a couple of different batch numbers here too. I've got the same ones. What the hell? These are all different batch numbers. I grabbed... No. I grabbed the whole pile out the fucking... Excuse my language. This just shits me. I grabbed all CHN 9... I know it when I see the number. No. Oh, these are the tip 32s I got. Sorry. I'm looking in the wrong bag. My God, I feel like an idiot now. They're all tip 32s. That is my tip 42. Okay. Have I muddled this up? 1, 2, 3, 4, 5, 6, 7, 8, 9. What's this? Okay. 41. 31. 42. Okay, so I grabbed all those in a different batch number, but these ones, I could only find some that I already had. Anyway, so what I'm doing now is I'm taking some measurements quickly of the ones I've got to see, because I do remember when I tested them, some in that box were different, but I rushed it, and I was like, oh, they're all roughly the same, you know? Well, I'm not having much luck here. Between what I already had from 3 years ago, all this that I bought from AliExpress, and this from JCar today, I still don't seem to have matches. The reason, if you're wondering why I still bought more, is because I bought a different batch, and these ones had a higher gain than the ones I had. So I grabbed them because it gives me more options, and then when I go and order, say, another lot from AliExpress or something, eventually I'll end up with a whole load of matches, right? This is how transistors work. You just got to keep buying them until you end up with matches. But the beauty of it is, whilst you might have to buy a bit and you have all these piles that don't match with anything, eventually you'll have matches for everything. It just takes time, you know? I'm just not having good luck at the moment. I mean, it is a first. Honestly, I've had really good luck with transistors. So this is rare. I mean, when I say luck with transistors, I mean matching them. But, yeah. So, I'm going to now select a few different types that I've got here. Different batch numbers. Measure them. Write it all on paper. I'm going to see what we've got. They're tip I'll just show you in a second. Hold on. Just give me one moment. Let me just test these. Wow, 273. Yeah, that transistor I just got there is definitely the same as what I just bought. And that transistor I've had for years. Look, that was 273, right? AE26 is the batch number, same batch number. Gain through the roof. $267. Fuck. Sorry, I don't want to swear, but this makes me swear. This really gets me annoyed because I just want to do this. So what I did was I bought tip 31s and tip 32s. Incidentally, they're not matched to each other either. I tested them all. I went there with this and a ZIF socket. And yet they let me do it. They know me, like they know that I know my shit. They know I'm not gonna like blow up the components, or snap legs, or do dodgy shit. So they usually just like let me knock myself out in there. I appreciate that. But I was not able to find anything matched. I literally went through both their drawers of tip 41s and tip 42s. I was going to buy 25 of each because they charge $2.45 for a single transistor, $2.20 if you buy 10, and if you buy 25 at $1.70. So I was going to buy 25 of each. I ended up coming home with 8 of each because I wasn't going to spend all that money on transistors that I've already got that don't match with what I've already got, right? But I bought tip 31s and 32s. I'll get to why in a minute. Well, I was low on them anyway. I literally had like 3 of one and 1 of the other. I'd almost run out, so I needed to get some. But what I'm thinking, I'm going to look at the data sheet on my computer. And because I'm tip 31s and 32s, as long as my output devices have got enough gain, it's not like I've got anything that's reducing their gain installed in the output stage. You know, like I don't have like feed forward resistor networks going from the emitters of them all back to a center point that's tied between here. You know what I'm talking about. Local feedback. I gone blank on the word for a minute. There's no local feedback. There's no base to emitter resistors. There's no, you know what I mean? So as long as I got high gain in there, I'll be able to use tip 32s and tip 31s. Now, they don't match with each other, but my 41s and 42s don't match with each other. So here's what I thought. I'm going to have to go online, get the data sheet up for both of them. If the transition frequency, the cob, the COF, all the different capacitances, you know, capacitance on base, the junction capacitance, the transfer characteristics, if everything checks out and I feel that I can mix and match 31s with 42s or 32s with 41s and get the HFE and VB matched and the other parameters do match, we'll do that. If not, we're just going to go for the best we've got, and I'll just have to, well, luckily they match VBA wise and it's only gain. And gain, I think I should be able to rectify the gain issue by just increasing the base resistance. Because the less drive it sees because of higher base resistance, the more it's going to need to current gain that, right? So if a transistor's got more current gain, I'll just drive it with less current. And that should still keep my two sides linear. We're going to see. It's going to work. It's not like it's going to go into oscillation or blow up or something terrible is going to happen. It's going to work. We'll make this work. But I get the feeling that I'm going to be changing transistors down the track as better matches come in or better devices come in. You know what I mean? Now, guess what I did the other day? Because that $50 note that I showed you wasn't all the money I had. I was planning on, I had $150 and I was planning on saving it. Well, I went to JCar and I didn't have $40 store credit. I used that last time. And I had $10 there, so I used that. Anyway, what I decided to do was just spend my money. Fuck it. It's one day. It's all good. I do need to save money, but spending money that I made in one day isn't going to kill me, you know what I mean? Like I can save every other day and spend a day's money here and there, you know what I mean? So I was just like, all right, whatever. So I bought all these. I went on AliExpress, found the seller that sold me the real output devices. I ordered more. And the same with those 1302s and what are they, 2381s or something? I can't think what they are. The green and black transistors that are like more solid than the 2SC5200s. I've ordered more of them too. Because something I've noticed when I order transistors that are board pools or old stock is when I order them like 1 month and then order them a month later, they're different transistors. And if I didn't get a match in my first order, the next order, the transistors are so different in terms of properties to the first lot, I end up with a match. So I just went and ordered more 2SC5200s, more 2SA1943s, and more of those other old school transistors. I didn't order any tip 41s and tip 42s because I just ordered these recently. They're still going to have the same stock. I'll get the same batch. It would just be a waste of money. You know, I don't mind spending money on transistors even if they don't match what I have, if they are different in properties to what I have, because when I get more in the future, like I said, I will end up with all these matches, right? So it's not like they're going to go to waste, but I'm not going to keep buying. This is why I only got 8 of each of these, because I'm not sure what I'm going to do with them for starters. And secondly, it seems like I've already got them. So I'm not going to go and buy. I think I've said enough. You get what I'm saying. So, let's see. 1, 2, 4. I'm starting to get things mixed up. Hold on. 1, 2, 3, 4, 5, 6, 7. Tip 42. Searching 1, 2, 2. Yes, that goes in here. I'm just trying to keep things organized. Let me. Oh, this was mine, wasn't it? Sorry, guys. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Put all these off over here. Let me just put. Sorry. I want these ones over here. Yeah, these ones. Let me just put mine off to the side for now. Now, so far out the AliExpress drawer, this is the diversity that I've found, right? So I've got 106s with a VB of 644, 168s with a VBE of 646, 182 with a VB of 643, and 272 with a VB of 592. And that's these ones that have got the ridiculously high number. So I'll just put those off to the side and I'll leave that there so I don't get too confused. Because I need to know where I've got all these from, what piles, so when I choose what I'm going to use. I think you all get what I'm trying to do here. I'm not explaining, I'm doing a bloody terrible job of trying to explain it, but you can see what I'm trying to do. Incidentally, I ended up just riding my push bike to J-Car today. My mate couldn't take me till tomorrow because something came up again. He's not bullshitting. He works 5 to 7 days a week, literally, and sometimes he works weekends too. Is what I'm trying to say. And he's got a family at home, like not like his kids, like his parents and brothers and sisters and stuff like that. They all live at home, and you know, his dad wanted him to go help with something, so I just jumped on the pushy and went to J-Car because I was like, I got to get this done. Like everything that I've tried doing in the last couple of weeks, I've been held up on, like drill bits, fucked up a circuit board I etched, waiting on the AD8130, which is here now, transistors that aren't matched. You know, I've just had stuff preventing me from getting my work done. So I was like, I'm jumping on the pushy. I'm going, I need the exercise. I haven't been keeping fit lately and it's starting to get to me. So I'm going to get back into training. Anyway, 116, 614. I can barely work when I talk. I'll still make mistakes, but I cannot write numbers and think numbers when I'm talking. 1, 1, 6, what was that? 644? 620. Alright. So, and when I was in JCAR, I tested them all. They're all literally the same ballpark. There's nothing different here. One might be 112, one might be 118, but they're all in this bag, in this ballpark. So now this is what I've got to work with. Let's see. What's the closest I've got? Hey. Oh, damn it. That's tip 42. See, the problem is that's tip 42, and that's tip 42. Let's just have a look through some of the ones I've got as well. Anyway, what I was saying before when I went off track is I'm going to get the data sheet up for the tip 31s and 32s because they'll be able to drive my output stage. We might, as long as, like I said, oh no, I did explain it. Yeah, I want to go check all the properties on them and see if I can mix and match like a tip 30. I already explained it, sorry. My mind is trying to get miles ahead of what I'm doing. I've already got them, eh? Oh, this is one of mine. Sitting here going, I've already got them. Yes, I do. That's why I bought these with the high gain. I didn't buy any more of these because all the other ones I had were the same as these. Oh, damn it, it's a tip 42. I already looked at these. This is just fruitless. You know what? I don't think I'm going to have any luck here. If I can just go back in there. 42, 106, 41, 168. I'm guessing these. Oh, the VBA is way off. Damn it. We really don't have much to work with. Those are 241s. Bucker. I might go through this box of 42s. See if I can find any with a higher HFE that's closer to that. Maybe we'll use them. We're getting there. We are getting closer, but it's really not good because I want to do this now. And like I said, I want it to be the way I planned on designing it. I don't want to change the design to, you know, suit odd transistors. 110, 170. That's still 60 HFE difference. I'm just going to turn my computer on so I can get the data sheet up for the tip 31s and tip 32s. Oh crap, my phone's ringing. One moment. Alright, well this batch seems to be all around 104, 106, and some around 111, 110, 112. So, see what I mean? These are at least 60 away from, and they're 42s. Ah. These, oh yeah, 41s. These are 60 HFE away from those. So at the moment, it's looking like that's going to be my option. I'm going to put these high gain ones back in here because I know I'm not going to be using those. 620, that had a really different VB, so I'll put them back away. I'm going to be using them now. Looks like we're still going to be going through these two boxes, strangely enough. And like I said, I'll get the data sheet up for these now. Alright, well I'm not going to do this on camera. I'll get the data sheets up. I'm not even sure if I've got to download them or if I've got them. I almost have every data sheet, but I don't have everything, so we'll see. I'll get the data sheets now and I'll finish going through all of these and work out what we're going to do, and I'll come back and I'll show you the results. Well, I'm not having luck so far. Out this entire batch here of tip 42s, which I've just gone through, I kid you not, one of them wasn't the 106 or 110 HFE that all the rest of them are. One was different. So I've put that off to the side and I've marked it because I've got a lot of different transistors here, including the ones on my amps still and that pile of new and used ones that are here. I've decided I'm not going to mix 31 32s with 41s and 42s, even if I can find that like the specs that I'm interested in are the same. The die size is still different, the voltage is different. I can just see it causing problems, and I just don't, you know, like, it's not the right thing to do by any means. I'm just trying to get this done. Look, I'll be honest with you guys, if today this ends up being a failure for me again, like the last couple of days, and I still can't get anything done, you know, RF projects, I've had to wait for parts and drill bits, which are almost here, but then I started doing this and haven't been able to find the right transistors. We'll start on that Sony Mateki system. I'm not going to give up. I want shit to do. I'm trying not to, you know, have 10 things on my to-do list at once, you know. I've already got a huge list on the back of my door of stuff that I need to get finished that's just sitting there and actually growing, not getting smaller. So I just really want to get, you know, yeah, stuff done. So now I'm going to go through this whole batch. I'm going to see if anything in here by some miracle has a low HFE, because these are all high, like 182, because I need something to match these at 106 to 112, or 100 to 112, to be honest, but then the majority of them are 106, 108, and 110, basically the same. All the VBs are the same. Now, when I was at JCar today, I deliberately picked these. Really nice of them to let me do that. I got to admit, because you gotta understand, the guys behind the counter, they don't know jack shit, right? And I've come in with this and asked to put their components in something with wires and power and test them, and for all they know, I could be destroying the components, but they still let me do it. So I got to say thanks to them, guys. That was nice. I grabbed these ones. I'll show you why I grabbed them first. Now that wasn't of interest, so let's just go there. These had way higher HFE than, see, 267. So I grabbed 8 of them. Just in case when I get that lot that did I tell you guys? No, I haven't, because since I was recording the earlier segment of this video, I've put another order online for more tip 41s and 42s. From a different seller, and the ST brand ones, like I've got, but they look like different batch numbers. They're going to be different to the ones I've got, so let's hope with all this and that I'll end up with, you know, what I need. Anyway, so I've got some of those that have got high gain. They're 41s. And I got some of these which are 42s, but these are just the same as what I already have. So that's why I only got 8 of them instead of buying 25 like I was going to of each, because I've already got them. These are just spares. So I'm going to continue going through this and hope by some miracle I can find 8 in here that don't have an HFE of like 175, 182, whatever. You know, it could happen, because in the other box they were all 110 and I found this one that was 135. Now, you know, if I can find more of those in the ones I've got, I might be able to build that pile up and then mix that with some of these that are closer to, like, I don't know, 160. It's still a little bit different, but looks like we're not going to get perfection here. I mean, I got it with the output devices, but I can assure you they're way closer matched than what you think they are. Where it looks like the VB is like a millivolt or 2 matched, it's probably closer, because don't forget I'm handling them and that makes it go up and down a millivolt, you know. So they're really well matched outputs, but I want my drivers matched. It's just, this is a shame. Anyway, I will continue doing this and report back soon. Well, I'm about to go through my ones that I've got, like here, and what's on there and there. So far I've got one straggler, 135, 642 for a 42C, and all of these were the lowest I could find in the 41Cs, so it came in at 159. So, you know, like, this isn't too bad. If I can just find more of these, let's just see how I go looking through what I've got now. I will report back soon. Okay, I've had a little bit of luck. So these all come in at 159 VB 645. They're all 41s, right? So I've got more than what I need there for 2 amps in terms of 41s. Now 42s, I've been putting all the ones aside that have got lower HFEs, right? Now, I've found a few, but the VBEs are way off. So I might not be able to use them. But I do have other 41s that have got totally different VBEs. So I might end up putting this pile away and putting the other pile here with them. What I'm going to do now is I'm going to take, all I've got left to go through, is I'm going to take the transistors off there, those 4 drivers, and those 4 drivers, and see what I've got. Now, if I can't do this because of the VBE numbers being so different, what I'm going to do is I'm going to use, say, the 41s that are higher, like that, and the 42s are even higher, like 270 or something. So instead of having, say, transistors that are, say, 60 and 112, it would be like 160 and 260, if that makes sense. Still have 100 HFE apart, but there'll be enough gain, because I need a lot of gain in this circuit. I'll have enough gain and I can just drive one side a little bit less, if that makes sense. The VB will be matched. And obviously this is only temporary, just so we can keep building the amp and, you know, have it going, and so I can have amps. Because I've got shit speakers running off a shit amp at the moment, if you want to call it an amp, which is not normally how I roll. I normally have like 2, 3, 4,000 watt RMS of speakers and subs and multiple proper amps in my living room. And right now I don't. So, because I've been slowly getting rid of stuff and built all my own speakers and sub boxes and crossovers and stuff like that in the last few years, and gotten rid of all the crap amps that I had, all not daisy chained together, but you know what I mean, or hooked up together to power all my subs and speakers. And then I started just powering everything off this monster power supplies, 2 monster power supplies, one I modified, one I built, and just run car amps in there. Really powerful car amplifiers, 4 of them. A couple 1,000 watters and a couple 500 watters was what I had in there last time for all my speakers and subs. And I was running 4 8-inch kickers in ported huge boxes that I built myself. They take like 300 watts RMS each, and we're being driven about that. And the speakers were taking the rest. I had 6 speakers in there. Anyway, I've still got all the speakers and subs. That's why I'm building proper amps now, because that's what I want to do. I've got that EQ that you saw in the other video, the PV EQ, the old school one. I want to put all the what do you call it? The filter caps in the feedback of each op amp for each slider. It's 16 band 2 channel, and it's got like low and high filters and stuff on it too. I want to put better op amps in the whole thing, make the power supply a bit better, and put better feedback caps for all the different filter values. So I essentially want to make the EQ better, build all my own amps, have that with my own subs and speakers. That's my dream system. That's what we're doing here, basically, if anyone's wondering. Like I said, I'm a bit of a music nut. Anyway, and that might give you some insight why I'm so ashamed of having this Sony Muteki system at the moment. But I was getting annoyed having these large power supplies in my living room going to power 4 car amps, and the cats were making a mess of stuff. They were ripping the surrounds on my kicker subs, and I was just like, you know what? I had a mate that was getting rid of that, like, next to nothing. Like, basically just selling the speakers because the amp was cooked, and I took the whole thing and fixed it, and I was like, yeah, I'll just use this for the meantime, you know? So that's what we're doing. Something else I meant to point out, where I've explained that I want to take maybe its transformer, maybe put a bigger one with it, or a couple of transformers, bigger caps, bigger bridge rectifiers, bigger heat sinks and fans, take the STK modules out, put heat sinks on them, and build a way huge amplifier out the parts out of that thing. I forgot to mention, like, I'm talking about building the whole amp, like, so all new circuit boards and everything. I'm not using anything that was inside that unit, if that makes sense. Yeah, anyway, so I'm going to get to taking these transistors off the heatsinks, and I'll come back and tell you what I think I'm going to do, but yeah. God. If anyone's wondering why I'm so concerned about everything being so perfectly matched, well, I'm trying to build really powerful amplifiers, right? Now, anyone that builds amps, anyone that uses amps, and knows a bit about audio, will know that the lower you go down in impedance and the higher you go up in wattage, the the harder it is to maintain low THD and all these nice properties that we like, us audio nuts. So that might give you a bit of insight into why I'm trying to do what I'm trying to do here. And the amplifiers I build, I'm using for myself and will have for a very long time. So I want to do a good job on them, you know? And we will do different things, like I said, try with current sources in different areas and without, and different transistors, and, you know, different levels of different resistor values for cross distortion, different bias currents. We'll look at all different things, you know, different output devices, and when we've got what I want, you know, that's what I'm going to probably have for the rest of my life for some of my systems. So I want to make sure that everything in it is as close to perfection as it can be. So I hope that answers your questions. That and the fact that the design sort of calls for it. The two just go hand in hand, you know. So, yeah. Anyways, I'll be back soon. I've got to take some transistors off heatsink, test them, and then we'll go from there. I'll tell you what, pulling apart all this point-to-point wired stuff that I had the amp built, like so, is proving to take time. I'm getting there. I am getting there. But it is taking a bloody long time. And I cut all the screws to custom lengths. So these screws here, they hold the diodes in the top. You got to take the screw out and the nut out before you can get to the nut that's on the back of that screw. Yeah. Anyway, I am making progress, and I've rechecked all the VBEs and adjusted the values, the VBE figures for today, because, you know, different temperature, different day. So this is all accurate. As you can see, I'm not having too much luck with VBE, but I do have others with similar numbers that have got VBE around that. So we're going to have enough to do 1 amp, but I don't know about 2 just yet out of these. Not too sure. I might anyway. Like I said, I'd be more happy to use, say, one of those ones that's got like 250 gain with one that's got 170 gain, than as opposed to having a 60 and 100, because I can always account for too much gain. It's a bit hard to make up for not enough gain, right? Yeah, anyway, I'm going to just, what I decided to do now is just blanket pull this down. I'm not sure if the output devices are smoked or not. I tested a couple and they weren't smoked, which is quite surprising to me. So, I mean, if they're not smoked, I might even leave, I don't know. I was thinking about leaving them on one heatsink, but no, you know what? I like those transistors that I'm using now even better. They're more high quality transistors, so I think I'll just put these devices to the side for another project. But these are genuine to C5200s and, C5200s and C1943Ns. So, yeah. Oh, and they are the high gain too. I'll show you. You watch the first one I test that I haven't tested already, you'll be blown, won't it? No. 73. It's not as high as what I thought it was. Wow. Are they all the same? Oh, there we go. I told you I smoked these amps. Oh well. Alright. Okay, interesting. Looks like I smoked one channel but not the other. That's kind of lucky. in that last clip, I managed to drop my phone. I managed to catch it and edit it out, but that's why we're picking up here and it seems a bit different. I'm clearing the heat sinks and I'm just basically getting all the mica for the diodes and these devices just going in there because the mica is still good. Anyway, heatsink screws going in this bag. The screws for the diodes are there. I've got to clean up these diodes because what I'm going to do is I'm going to cut the legs down really short and I'm just going to run wires. They'll still be linked to each other like this in series, but in the middle of the two sides will be a little circuit board that contains the bias adjustment and those resistors. This here. So you have the diodes on the heatsink. I can show you because I've got this here. So what I want to do is I want to trim all these legs back in so I can make these links out of insulated wire and right up where the thicker part of the leg is that doesn't bend. You know what I mean? And then here will be a little PCB mounted where you can set the bias and it has these resistors and all that. And obviously a wire coming down off of it that will be shielded, that will go somewhere. Well, it depends. One preamp design I have runs through a 4.7 mic cap and a 22k resistor to ground to drain the cap into the middle of the bias point. The other preamp design, that's that preamp design. The other preamp design has gone hiding. Okay, now I'm building a new battery box because of those oscillating regulators. I've got new ones and they oscillate too. What on earth? Wait, it's on this paper. No. Oh, yes. So, and incidentally, this 100 mic cap, if I do end up using this network for this, because this will have incredibly high input impedance, I won't need 100 microfarads there to pass down to, say, almost 0 hertz. Yeah, I'm a bit of a bass nut. I want all my subsonics to go through, not just 15 hertz. Sometimes I want my subsonic filter off. So yes, the cap value still needs to be low, but it probably won't need to be 100 mic for this. That's just for that because that has a higher input impedance and therefore needs 100 mic to pass the low frequencies. Anyway, I'm going off topic now. I got to clean these up. The other annoying thing about this is some of the screws are stripped out. So as you can see, there's a screw coming back in the heatsink with a bolt on this side. Yeah, that's a pain in the butt. It's all right. It's what I've got to work with. What condition is this heatsink in? Okay, much better. We've got one there and one there. That's good. As long as I'm gentle with the screws, I should be okay. It makes sense because that would be, because I see that there's a couple of extra holes that look like I drilled them there for something. Those are TO92 inserts. Those were factory. But if we come over to this heatsink, we see the same thing going on there, but we see holes in the middle and another hole there. So this would have been my prototype. I sort of built an amp in the first place, and then I wanted to build two of them. So I pulled it apart, harvested the parts, got more parts, and got the other heatsink and started building two. This would have been the first one, and probably had a VB multiplier board screwed onto here. And I probably had like a transistor trying to sense temperature on there or something like that. I can't remember, Maybe that's what I was doing here too. I really don't remember, but yeah, this heatsink's got a few stripped threads because this got blown up, like 10 times in the design process. I was learning at the time. And yeah, I also didn't have a dim bulb and stuff like that. But yeah, so I'll be back soon. I'm just pulling transistors off, particularly these small ones, I'm just taking those off both the heat sinks now and the diodes, because I've got to clean up the diodes because I want to reuse them. I do have more of them. I've got oh yeah, there we go. Those are BY229s, those are NFK15G or something like that. What have we got in here? MBR 2020s, something like that. 2200, sorry. So hard to remember everything. I wouldn't honestly mind using a different diode. I don't like using BY229s for, you know, running a few milliamps through them for temperature sensing, but I don't. See, I did a lot of experimenting with this, right? So I had actually glued different types of diodes in glass capsules, plastic diodes like 4007s versus 4118s versus Schottky diodes, TO126 packages. I tried screwing them in parallel with this screw, like on top of the transistor with another one on top of it. I tried all different methods of this temperature sensing with a diode junction, basically, right? And believe it or not, with the transistors there, and no, that's how this heatsink was in the amplifier that I got it out of. I know it seems funny, and I thought it was a bit funny too, because heat rises, but I cranked the crap out of this, and it ran fine with no fans. 250 watts a side into 4 ohms, so bit of magic, that heatsink. I'm going to put fans on it this time to help pull the heat through as it wicks the heat off the bottom fins. It'll make that, yeah. Anyway, point I'm getting at is basically because of where they are, and that's like just above them, with this being thermally coupled really well up to the heatsink and the diodes sitting on mica just here, the thermal tracking I got was just amazing. Like, you would literally just turn it on and you just look at the what do you call it, the bias, and you watch it literally just come up and just go, it would be like, and just sit there. It was bloody beautiful. Like, it took a lot of experimenting with different diodes and different transistors to get that to work like that with that string, but I replicated what those SAP 15 devices do. Now, the thing is, I want to continue doing that. So I want a device I can screw onto the heatsink with a metal tab. And, you know, the unfortunate thing is the only devices that I have lying around here is stuff like Schottky's, fast rectifiers, you know, for switches and stuff like that. You know, double Schottky's. Mixed diodes, TO220 type. Yeah, okay, there's only a few random ones in there. Yeah, you see what I'm saying? It's not... I don't really have many options. And to tell you the truth, like, if you think about it, TO220 devices are power devices, right? They're sort of your, you know, you've got your TO92s and your TO126s, which are essentially the same die. And then you've got your TO220s, and then you've got your TO247s, TO3s, TO3Ps, your TO3PL, you know what I'm saying, right? Which are your power devices. Now, it's going to be very hard to find a small diode in a TO220 package that's cheap. You know what I mean? Leave it in the comments section if you know of one, and I'm wrong there. I will be ever so grateful for that. Seriously, I really mean that. If you know of a TO220 device diode that's got good thermal characteristics for tracking a transistor's temperature, that's the other thing. That's the other thing that the BY229s tick the box of. They work perfectly. Leave it in the comments. But anyway, I'm going to continue with the BY229s. Look, it's not like I hadn't already built 3 amps with them. I've owned them for years. I've already restocked. So I might as well just continue using them. That's why I'm salvaging them, because there's no way I'm going to go and waste another set of these again. You know, I forget what the spec is on them. I think they're like 600 volt diodes, 6 or 8 amps, 4 amps, something like that, you know. Way overkill for the job. So, yeah. Anyway, something else I wanted to show you guys. I thought this is absolutely hilarious. Leave this in the comment section too. Have you guys seen what happens when people use AI to try and replicate like a circuit board, and it weaves all those, like, the circuit board looks like a pile of wires just like meshed together, and capacitors don't look like capacitors and all that sort of crap? You know what I'm talking about? If you don't, go have a look at AI circuit board pictures. Just Google it. I'm sure you'll find that it's bloody hilarious. I got the new J car catalogue. Guess what they did to the front cover? Just take a moment to have a look at this. That is just terrible. That's terrible, Muriel. Really? Man, that's the sign of the times we're living in. People can't even be bothered designing their own cover anymore. ChatGPT. Make a futuristic looking circuit board that looks like it's a city that's being built by a 3D printer. And they probably looked through like the top 3 results and was like, yep, that's the one. And that's what we got. Well, they could still do the back cover. What's wrong with the front cover? Jesus. I just thought I'd point that out. That's just... Look at this shit. Seriously? God. Yeah, that looks like a highly functional circuit. The fucking future of AI. Anyway, I'm going to continue doing this. I'll be back soon once this is all pulled down. What I intend on getting done tonight is matched, or like my set of tip 41s and 42s decided upon, and the heat sinks repopulated with the new TO220s and the new TO... What are these, 247s? Yeah, they'd be TO247s. So the new TO247s and the new TO220s. I want populated on the heatsink tonight, and these diodes populated on the heatsink tonight, but I want all their legs clipped up so that they don't... One, the smaller everything is, less inductance. Two, it's self-explanatory. Yeah, so that's what I'm going to do. I will report back soon and show what I've done. But we're basically up to the building stage. I've just got a little bit of work to do here for the next hour or so, and I'll be up to assembly. Alright, so I've got everything off of here. What I'm going to do now, because I've got some screws that I've left in there, because they're the ones that are screwed back with bolts on this side. So I've left them in there. I'm just going to go and clean this up, sand this down, make it all nice and pretty, pop it off of this piece of wood, and repopulate it. Reason being is because I've got all the exact numbers of spacers and screws and nuts for everything for this heatsink, if that makes sense, because it's got a certain number of studs, right? So I'll populate this, and then I'll do the same thing with this. But what I have to do first is I have to just take off these 4 devices here. I don't have to worry about everything else on here, but I just need to take off the 4 drivers, because I need all the drivers over here so that I can finish working out what I'm going to do. But these output devices that I've matched the other night will be getting fitted to the heat sinks and the drivers, and the heat sinks. I'll pop one off now. Hold on. So there we go. As I suspected, I've just got to go get my grinder and just clean that up. That's fine. I mean, I might not even need the grinder. I can probably, yeah, I reckon I can get a Stanley blade under here. Anyway, like I said, we're getting there. They're nice heat sinks, just to give you an idea of size. You know, they're good. Honestly, wouldn't mind mounting the transistors right here, just below this lip here, and mounting my diodes here. think I might do that. I don't see any reason why not. To my mind, it would cool better. The heatsink does have this little, like the top bit comes out a bit further, but I don't understand why you'd mount your power devices up here with all the heatsink going down the bottom. I know it is fan assisted, but if you know about thermo design like this, leave it in the comment section, because I'm inclined to mount my devices along here and here. Anyway, these literally just there's the other one, and I've just used this, so that's that problem solved. So I am getting there. Like I said, with all the screws going in and out, different angles, the point-to-point wiring, the bits of wood, you know, it's a little bit of cleaning up. Plus I still got to clean up the bits of wood on the bottom of the heatsink. I'm going to desolder all these bits of wire. I've got a little bit to do. I've got transistors to match, but the last few days I meant to get it done, and today I've actually had time to do it, so that's what I'm doing. It's only 7 o'clock right now, so I've still got hours. So by tonight we'll have 2 populated heatsinks. Alright, so I'm just having a look at data sheets now. Did I say BC5551? I meant 2N5551. I just went to type it in because I can't remember what the current, like the collector current or the breakdown voltage is on it. And when I went to type it in, I was like, did I say BC5551? It's getting late, it's 11:38. I'm actually really proud of this. Last night, I actually made it to sleep by about 1 o'clock. Can't believe it. Okay, that's a lie. By the time I actually slept, it was probably closer to 1:32, but I had turned the lights off and started to relax and try and go to sleep by 1. The last few nights, I had stayed up till 3, then 3:30, then 4, then 5. And that was when I was like, right, I have a problem, I have to do something about this. And it just so happens that the day I got a little bit of work, I had to go for a bike ride to J-Car the next day. So not having much sleep and then doing that sort of took it out of me. And I think that's why I got to sleep early. And it's 11:39 now, and I'm getting tired, which is good because I don't usually start getting tired till about 2 o'clock in the morning. Oh wow, 2N5551's at 160 volts, 600 milliamps. Let's have a look at what the cob is. Six picofarads. What are A42, MPSA 4292? What are they? Let's see. MPSA 42 on semi. Why is my internet being slow today? Come on, come on. We don't have all day. The people want to know. I want to know. I think what I've decided to do is we've already got way better output devices. So the output devices that I'm using, not the 2SC 5200s and 2SA 1943s, are not for audio, but the NJWs, 0302s, 0281s, and their, is it 3202 and 3281s? The 150 watt and 200 watt devices, they're actually produced from the wafer, like from the fab, to be linear. So the NPN and PNP parts are very close to each other. They're only really sold in tight tolerances. They're designed as an improved output device. I'll show you the data sheet in a sec. Let me just get this data sheet. So we've got way better output devices, right? Our drivers now have got, you know, we had one driver on one side, my NPN drivers or PNP, one of the two. One was 50, 60 HFE and the other was around 100, 112. Now we've got 112 and 160, so outputs again. Before we had HFE as 75. So we've got linearity on our side and gain on our side. So I think what I'm going to do, let me just get the diagram again so I'm not just wafting on here and people don't actually understand what I'm talking about. There you go. Right. Yeah, had to have a good think about this. I designed this, I'm pretty sure from memory, I had 16 millivolts across the 0.22 ohm resistors. I could be wrong, I haven't done the math on that, this is just from memory. Like I said, I did build an amp, this is a bit different because I've started modifying and improving it, but I did build this amp and it worked, so from memory that's what I had. Now, the 200 ohm resistors, I might increase them to say 110 ohms or maybe 150 ohms or 120 ohms each, so that the total resistance is maybe 220, 270, 300 ohms, something like that. Probably won't, because like I said, the cob on these is bigger than what I had before, so I can't imagine them wanting to switch off any easier. So that's probably going to stay 200 ohms. But this 820 ohm resistor here, I'd like to see, you know, upwards of a K, a couple of K, you know what I mean? Like quite a few K if I can. But these base junctions need to discharge quick enough. Now there's only 10 ohm resistors, so it's not like the resistors are really having much of an effect when it comes to speed, because as you all know, if you don't, now you do, the reason why I've got low resistances in here is because I'm trying to use, you know, linear devices, so I practically don't need base resistors. That's why I've just got low values in there. That's just there for a little bit of damping. That's all I've got them in there for. And you know, a little bit of current sharing, but it's basically there for damping and current sharing on the output devices, but the emitter resistors basically do that and obviously provide a little bit of feedback too. Now, I would like to get this bigger, so providing, right, these base junctions can discharge quick enough, and providing the outputs of these two transistors can turn off quick enough, I can increase this. Now, I believe now I've sorted out the transistor problem, this should be working a lot better. And if I put different transistors in here smaller than what I had and matched, I should be able to do that. Now it's going to throw out my bias, so having more gain everywhere and transistors here with more gain means that the bias is going to go up, so these resistor values will have to get increased, the 233K resistors. Possibly some of the resistors here might have to get changed. I might, you know what, it's always a good thing to get these values smaller, right? The problem is making those smaller means that this is going to conduct more current, right? Which is going to pull current away from whatever you have here, current source or a resistor. It's going to pull current, you know, through the diode network and back there, right? So, yeah, I think I've explained enough and you guys can understand what needs to be changed. So what I think I'm going to do is I'm going to go for it with the different transistors. I've already got different outputs. I've got way better gain and linearity on my drivers. So I think what I'm going to do, change these as well. And, you know, I don't have to power it up on plus minus 55 volts. I can power it up on 30 volts. I can power it up on 60 volts across from rail to rail. I'm saying, like, you know, plus minus 15, plus minus 30. See what the bias current is. Adjust the resistor values. I don't have to power it up and worry about things pumping too much current through these transistors or too much bias running here, you know what I mean? So I think that's what I'm going to do. So I'll have a look at these data sheets. Actually, I've got, oh, bloody hell, man, I get a sore back. Let me explain. I'm a push bike rider. I have this thing because I've done, as I've said in earlier videos, dumb shit when I was younger. And I like to keep fit now. And one day, I mainly obtained that by, you know, trying to do physical work and riding a push bike. And I came off my push bike one day, going for a ride, doing about 40-50k around the roundabout, and I landed on my shoulder and pushed it back. And now, my collarbone, I don't know, I'll turn the lock off. I don't know if this shows on camera, but if you see, it's still recording, right? If you see that lump there on my shoulder and how weird my shoulder looks on top, and compare it to my other shoulder, I'm sure you can see a difference. Yeah, I snapped my bloody collarbone. And I'll tell you what, it's not fun. Basically, the collarbone, it's got a ligament that pulls it down from the end and a ligament that's closer to your neck that pulls it down. What happened is a piece of bone splintered like this away from the collarbone, being this index finger. It didn't break off the end and end, it's just opened in the middle. So then what happens is your body fills in that gap with bone. So now I have my collarbone with this extra lump of bone off of it, and the tendon's still attached to that. It just means that the collarbone's now sitting up like 2 centimeters higher, and everything in my back's jacked up in the area. And I find it really bloody annoying. And I've been to so many doctors and had x-rays and physios and everything look at it. Oh, you'll be alright because you keep yourself fit and exercise and that. You'll be surprised. What? Listen, mate, I'm telling you, I'm in pain. And they keep arguing, oh, you'll be alright, you'll be alright. I'm like, look, if I'm 33 now and it's causing me problems, I don't want to even know what it's going to be like when I'm 90. So I'm trying to get someone to see the logic behind that and fix it for me. But I can't get anyone to agree that I even need it fixed. And you guys can see that. I've got a bloody lump sticking out my shoulder. Oh, God. Anyway, now I've gone off topic. Sorry, I do that. Oh, yes, the data sheet for the MPSA 42. I went to lean over to grab my mouse and click, and my back just hurt, and I had to stretch it. It messes with my tendons. I'm always having to stretch it to keep it straight. Otherwise, you know, I worry it's going to pull out my discs and stuff out of alignment, because it's literally pulling my back out of alignment. I have to do certain things to keep it in alignment, basically. I knew these were high voltage. So they're 300 volt parts, but they're still 625 milliwatts. Let's look at the gain. Oh, 3 picofarads. I like that. The cob. I can't see the output capacitance here. The 5551 ones were 20 picofarads, by the way. Let me see what the HFE is. Oh, okay. These have got bugger all HFE. These are good for current mirrors and stuff like that, I guess. Alright. One sec. I'm going to have a look at 2SC 1815s and their counterparts, 1015s, whatever they are. I have all these transistors in plentiful stock. That's why I'm having a look. It was only the output devices and the drivers that I was having trouble with. So from here, I've got everything else in my lab in stock to just build, you know. No, I'm not a robot. Bloody hell. You serious? I just typed in 56525. Trying to make me feel like I'm a robot. I'm not a robot, I told you. Give me my data sheet. Thank you. Alright, so these guys are 60 volts collector base voltage. Collector emitter voltage 50. Okay, can't use them. I mean, I've got, let's have a look at 2N3904s, 2N222s, BC546s. Let's compare them. I've still got some others I was just thinking about too. Just let me, okay, I've got these data sheets. This will only take 2 seconds. BC546. Okay, got that. 65 volts collector emitter, 80 volts collector base, great. That fits the build. 625 milliwatt power dissipation, yep, that fits the build. 4.5 peak cob, picofarads, yep, that fits the build. The output capacitance, typical 10 picofarads, input capacitance. That's pretty good compared, that's half of the other device I had. What's the HFE? Oh, beautiful. That's what I thought, they were high, yeah. Okay. 549s are low noise, aren't they? 1 second. Alright, AC 549s. Oh yeah, no, the voltage is way too small on them. Okay, so BC546 and what do you call it, 556, I think's the counterpart. That's going to work. MPSA 42s won't work because they don't have enough gain. So I'll shut that tab. 5551s. Okay, not the best in terms of input output capacitance, and current gains okay. So, what was the voltage on them? Yeah, no, they are usable. I would prefer not to use them though. I would rather use 546s and 556s. What's the transition frequency? We've got current gain bandwidth product. Collector current 10 milliamps, VC 5 volts, frequency 100 megahertz. VC 546, typical 300 megahertz. Let's have a look at the 5551s. Okay, they're slower. Okay, I'm going to shut that tab. Okay, 546, 556 is something I'm thinking about. I've got one other device that I'm thinking about. 9013s, 9012s, 9015s. Oh yeah, I was going to look at 3904s. Actually, I'm going to say they're going to be too low a voltage. I'm pretty sure they're only like 45 volts. 9015. Okay, I've typed that in wrong. No, I haven't. Let's try S9013. S9014. Okay, that comes up. That was weird. I know that transistor exists, I have it. 87553 because I have to prove I'm not a robot to download this data sheet that I don't have. Alright. Yeah, no, the voltage is too small. Ah, preamplifier, low level and low noise. Hold on, I've got ones with a different part number. They might be higher voltage. Okay, let's go back. S901, is it 5 and 6? Let me just go back to my parts drawer. My apologies. 9015, 9018. I've got 9012, 9013, 9014, 9015, 9018. Let's see what 9015 is. God, 09 bloody 652. Give me my data sheet. 50 volts again. Really? I would have thought. Alright, let's go S9018. Although that's not going to help me because I need both of them. Wait, that's not the transistor. Oh yeah. Come on, give me the data sheet. 07261. Right. 30 volts. Okay, so case closed. I think we're going with BC546s and 556s. BC327s have got a low voltage too, don't they? BC327s. So I've got heaps of transistors, but this circuit's running off a high voltage. That's the one little problem. BC327, 50 volts, 45 volts. Okay. What about S9012? Does the voltage go up when we go down in numbers? God, just give me the data sheet already. Oh, I see. I typed in a backslash. That's why. All right. I think I found a data sheet. Oh my god, it's even worse. 40 volts. All right, not having any luck there. I'm just going to pause the video and have one last look at everything. Okay, I found some more candidates. I've got some A1268s and C3200s, and I've got A1266s and C3198s, and quite a substantial amount of them. I've also got 2N3904s and 6s, whatever they are, 8050s and its counterpart, and 2N222s and 2907s, whatever they are. So I'll have a quick look too at them. 2N2222A. Let's see. $50 volt. Nope. Okay. 2N3906. How many volts volts, 40 volts. These would all work if I had current sources and stuff that were dropping voltage, but because they, like I said, running on a high voltage circuit, it's not going to happen. What about S8050? $40 volts. Maybe I already looked at that one. Hope not. Alright, well, let's have a look at these. I know these are audio transistors from amplifiers. A1268, A1268. How many volts? Better type in another number, 748, 24. Alright. Oh, 120 volts, 625 milliwatts. Oh, nice. Got a good noise figure. 4 picofarads cob, 100 megahertz transition frequency, which is fast enough. Just, I wouldn't mind faster, but what's the HFE? Oh, 200 to 700. Okay, we've found one candidate that I like more than BC546s for this job. Oh, the collector current's only 100 milliamps. That's too small for this. Okay. Goodness. Let's have a look at A1266. That's all I'm going to look at. I do have some other transistors lying around, but I don't have big quantities of them, and I'd rather keep them for when I have to fix something and I actually need that transistor than to use them in something that I could use a lot of different transistors in that I'm designing myself, if that makes sense. A lot of my component drawers are like that. Just because I have everything, it doesn't mean I want to use everything. If I don't have a lot of it or it's obsolete, I'd rather hold on to it, like I said, than use it in stuff that I'm building. Yeah, no, they're too small a voltage too. So, funny as, 546s and 556s it is. I'll go grab some and we'll start matching. Alright, these are the ones I have that are just from JCar, and I know that are a decent brand, not just some crap. Not that JCar gets the best stuff in the world, but I didn't get them from AliExpress or something like that. Let's have a look and see how hard it's going to be to match some of these. $252, love it. $728. $294, $721. I don't think this is going to be hard. I'm going to leave these here to cool off for a bit because I've been touching them. I'll spread them out so it's easier for me to pick them up with the clip so I don't have to touch them at all. And I'll match some sets out of these and I'll come back. I'm not going to make you watch me match sets. The reason why I went over the transistor data sheets on camera, well, not that you could see me, but you could hear me talking about it. It's just so that if anyone's doing this sort of thing, they get an idea of what to look for. And also, if you're trying to do a very similar amp to this, so you don't have to waste time looking up yourself, I've just told you all the voltages on them and some of the gains and characteristics of some of the ones that were close. So, but I won't bore your time with me doing this, so I'll be back when this is done. Alright, well, I did just record me putting the transistors, which I got nicely matched pairs, in here. That close. So what I did is I put the 298s and the 289s at 724 with the 243 and the 245 at 733 and 731. and I put the 238 and the 241 at 732 with the 274 and 273 at 724, 725. These are only in the buffer circuit, they're fine. So we now have all our diodes for thermal regulation and all our transistors ready for our 2 amp builds. Got all the screws and everything sorted out. Heat sinks cleaned up, ready. I've got to glue these coils tonight. Actually, this can come back up on the bench because this is, I've already started putting components aside because, like I said, I want to start playing around, experimenting with preamplifier design now. So, yes, those 100 mic caps will be smaller. That's the input stage for. Oh, I already explained this earlier. Yeah, one topology, not the other topology, but the rest of it will stay the same. The 15k load and the 560 input. All right. Well, I'm gonna start work on designing a input stage, or I might get to work on populating the heatsink, but I'm going to leave off on this video here and get started on the next one. If you got any comments, feel free to leave it in the comment section. And I guess I'll see you on the next video. If you haven't already subscribed, please do so and hit that like button. Thanks, guys. See you next time. Just one more thing, I did some research on this. Because this aluminium is so thick and the way this sort of goes out like that, because the heat wants to rise, but the thing that we're not thinking of is convection. Now, I don't know if it's apparent on camera, but this piece here is really, really thick to get the heat to go through, to get the heat to go around this bit. And that's why this is also back a bit. And especially with fans on the front pulling air through here, it'll actually be pulling heat into the heatsink, even though the transistors are mounted on the top. And I know that the research isn't wrong that I just did, because like I said, and as you can see, I had this built like this before, and I could load the shit out of it, and I didn't even have fans running, so that's what we're doing. Exactly how they were. Alright, see you all soon.